Okay, good afternoon. Lesson 3, Exponential Growth. So I have included my entire slide deck from today's lesson in this video. I am not going to go over every single slide on this video, just so you know. I am going to point out the most important things. My suggestion would be to have notebook handy, also a calculator handy, just in order for you to be able to take notes. All right, so here we go. This was our connector today. I am basically skipping through this piece. All right, so you were asked to find matching pairs in this activity. So basically, if you were in class today, you noted that y times y times y times y is y to the fifth. And if I were to go AB to the power of 3, that means I would take AB and multiply it once, twice, 3 times, because the exponent tells me how many times to multiply something. If I were to see 10 to the power of 1, that really just means I'm multiplying 10 one time by itself. That's it, which is 10. Y to the power of 9 means, if you were in class today, you would have gotten this as y times y times y. How many times am I going to write y? Hopefully you're noting that I would write it 9 times. So far I've got, what is that? 7, 8, 9. That's what y to the power of 9 is. And the only one that's not on here would be 8. If I were going to write that as an exponent, that would have been 2 to the power of 3. I know that because 2 times 2 times 2. So that's what we started the class off with. All right, moving right along. Lesson 3 was on representing exponential growth. So we did a math warm-up. That math warm-up enabled you to be able to tell me what was a certain pattern that you recognized. So remember, 4 to the power of 5 means 4 times 4 times 4 times 4. All right, so what we're doing now is we're looking, instead of 4 to the power of 5 and what it means, I want to know, what does x to the power of 0 mean? Well, this is where I ask students to look at a table. So in the table, we were asked to look for a pattern in what we noticed. So this x represented the exponent, which represented how many times did you see 3 being multiplied? How many times? I saw it being multiplied 3 times. So if you were to extend this, students were asked to extend it, and note that I would have then wrote 3 times 3, and then I would have wrote 3, and then all of a sudden we get to 0, and this should be 3 to the power of 0. Well, then I ask students to fill in the next row, and 3 times 3 is 9, and 3 times 3 is 9, and what is 9 times 9? 81. So then 3 times 3 is 9, 9 times 3 is 27, 3 times 3 is 9, 3 is just 3. I'm not multiplying it by anything. 3 to the power of 1, 3 to the power of 2, right? 3 to the power of 4. So this is 3 to the power of 4, which is equal to 81. 3 to the power of 3, which is equal to 27. 3 to the power of 2, which is 9. 3 to the power of 1, which is 3. So then I asked students, hey, do you guys notice any patterns here? And a lot of students said, well, I see that it's decreasing. Absolutely. How is it decreasing? One student said, well, that they noticed that they kept, there was something about 3, because they knew that when I go from 9 to 3, I was dividing by 3. 27 divided by 3 is 9. 81 divided by 3 is 27. So then we get to this 3 to the power of 0. And if I ask you, what is 3 divided by 3? you'd say, well, Mrs. Hannaford, it's 1. Therefore, right here, that is what 3 to the power of 0 was. And then I extended it by saying any number or any letter that's raised to the power of 0, the answer is always 1. So that means 4 to the power of 0 is 1. 10 to the power of 0 is 1. X to the power of 0 is 1. 1,000 to the power of 0 is 1. It's all 1. If I did this, A times B raised to the power of 0, A times B raised to the power of 0, this would be equal to 1. Believe it or not. And how do we know that? By following this pattern, that it is decreasing and I'm dividing each time. All right, so now, then I asked, hey, let's try a few of these on our own. And I asked students in a draw it slide to do this. So what's the value of 5 to the power of 0? What's the value of 2 to the power of 0? Well, remember what I said. Any number or letter raised to the power of 0 is always 1. So therefore, I could say 5 to the power of 0, easy peasy, 1. 2 to the power of 0, easy peasy, 1. Right? It's just 1. Let's go over here. Y to the power of 0. Remember what I said. It's 1. Times y to the power of 0. What is it? 1. What's 1 times 1? 1. Remember what I said. Any number raised to the power of 0. Any letter raised to the power of 0. All right, now here comes one. Problem 2. I stumped a few students today. So I've got 9 to some power times 9 to the power 7 equals 9 to the power 7. Well, think about it. If I multiply something and I end up with the same number, i.e., look at, what's 3 times 1? You'd say 3. What's 1 times 3? You'd say 3. Okay, so some number times 9 to the power of 7 equals 9 to the power of 7. Well, I'm ending up with 9 to the power of 7, so that means this has got to be 1. Therefore, what do I know about exponents? What something raised to the something power is always 1. So hopefully you said 9 to the power of 0, because 9 to the power of 0 is 1, and 1 times 9 to the power of 7 is 9 to the power of 7. Awesome. Moving on. Then what we did was I said, hey, right there, grab that lesson notes handout. Well, I'm going to give that to you at the end. All right? That's what I'm going to skip over, and we're going to talk about growth factor. So I'm going to skip. There it is right here. All right, let's take a look here. Here's that document. You might want to write this down. You've got time, right? Because nobody's rushing you through this. So I've got a biology lab. And in the biology lab, we've got 500 bacteria that we're watching. And it is reproduced by splitting. Okay, you got this 500 bacteria and is reproducing. That means it's multiplying. It's getting bigger. And how is it growing? Every hour, on the hour, each bacterium splits into 2. So remember when we did the bacteria at the beginning when we did lesson 1. So I've got one bacteria that splits into 2. And it keeps going. This bacteria then splits into 2. Each bacteria splits into 2. They keep growing by 2. Okay, this is what's going on. Every hour, it's splitting into 2. What does splitting into 2 mean? Hopefully you know splitting into 2 means to double. And I want you to remember that when I double something, I am multiplying by 2. So this is what we did, was we filled in this table. So I started with 500. That's time 0. That's my initial. This is the initial. That's how much I start with. Okay? After 1 hour, remember 500 multiplies by 2, so that means I've got 1,000. However, I want you to write it like this: 500 times 2, because it's doubling. All right, so now what happens at hour 2? Well, remember, this is 1,000, and I'm going to double it, so that's 2,000. And remember what I said, I want to rewrite it to show my initial value of 500, and then every hour it doubled, so I can go 2 times 2. We're going to do one more, and we're going to keep going. So now I've got, so if I double this, what do I get? 4,000. Okay, remember, I want to rewrite it, so I'm going to go 500 times, well, now I'm in hour 3, and it doubled again, so now I'm hour 3. There's 2 times 2 times 2, and I can do that again. 500 times 2 times 2 times 2 times 2. Oh, in 5 hours, 2. How many times do you think I'm going to write 2? I'm going to write it 5 times. Oh my goodness. Do you guys see a different way that I can do this? Do you see how I can like shorten this up? Let's try this with 500. 500 times, and instead of, look at, I've got 1, 2, 3, 4, 5. I could have written 2 to the power of 5. Could I have written 2 to the power of 4? Could I have written 2 to the power of 3? Could I have written 2 to the power of 2? Could I have written 2 to the power of 1? Do you see this? 1 goes with hour 1, 2 goes with hour 2, 3 goes with hour 3, 4 goes with hour 4. So what do you think I'm going to write for 6? I'm going to write 2 to the power of 6. That's what that means. And what happens if I write t? That means it could be any value. Could I write 500 times 2 to the power of t? Absolutely, I can do that. So this is critical. Make sure you get this down. Remember, my exponent has to do with the hour. The number is how many times I am multiplying 2 by, right? All right, 2 to the power of 2. Why am I multiplying by 2? Because I am doubling my bacteria. And I got that from my problem. All right, so we just did this expression, the number of bacteria after each hour. So what did I do? 500 times 2 to the power of t. 500 is what we started with. 2 is because I am doubling. T is the time. In this case, it's hours. You guys just wrote your very first expression relating to exponential growth. So now what we're going to do is we're going to write an equation representing n. N is the number of bacteria. So basically my equation is I can figure out the number of bacteria n by taking 500 and multiplying it by 2 to the power of t. What is 500? 500 is my starting amount. 2 is because I am doubling it. And I am using t because it represents the number of hours. So now what we're going to do is we are going to use our equation, and we are going to evaluate or find when t is equal to 0. So What that means is we're going to find n is equal to 500 times 2 to the power of 0. So take a look at that. What do you remember that I told you about 2 to the power of 0? I hope you're yelling at the computer going, it's 1, Mrs. Hannafarth, it's 1. So therefore I say to you, what is 500 times 1? N is equal to 500. And what does it mean? It means this is what I started with. What I started with. The amount, the initial amount. Go back to your table. Look here. At time 0, 500. The initial or the starting value. The initial or starting value. All right, let's keep going. All right, so now I've given you another situation. Got a biology lab, a population of parasites this time. Forget about the bacteria. Now we're talking about parasites. So it says it reproduces hourly, just like our bacteria, right? Okay, an equation gives the number of parasites, P, after T hours. Here's the equation. I'm going to write it right here. P is equal to 100 times 3 to the power of T. So we need to do some explaining here. It says, explain what does 103 mean in this equation. So think about it. Okay, I'm going to go back up to the table. Remember when we wrote this equation right here? 500 came where? Right here. At the initial amount. Notice the 2 was because I was doubling the bacteria. And T was simply the time. So now let's take a look. 100, I'm hoping you figured it out. 100 is the starting amount. Starting, the initial. What I started with. The initial population of those single cell parasites. What else do I know? 3. 3, instead of it being 2, it is 3. So this means tripling. I am tripling my numbers each time. And T, we didn't have to figure out what T was. All we had to do was go 103. 100 is my starting amount. 3 means I'm tripling every hour. All right, then what we did was, believe it or not, all we did was we went on to Desmos and we graphed these equations. And basically, I'll give you a quick heads up that we looked at when T is 0, when T was 100. So that just means that if I were to graph this, if I go back here, remember, what did I start with? I started with 500. That means when I started, I would start with 500, and it's growing exponentially. So this is an exponential graph. This is the key. This is my starting amount. This is the piece you need to know right here. This is 0,500. It is the initial amount. If I go to the second equation here of 100, that means I'm going to start my graph down here at 100. Right there, this is 0,100. And this too is going to grow exponentially. But this one's going to grow by 3. This one's going to grow by 2. So that's what you needed to know in this problem, in this lesson today. That when I write an equation, y is equal to, and I can just write an equation of 400 times 2 to the power of x. I can write the equation y is equal to 1,000 times 3 to the power of x. I can write y is equal to 850 times 10 to the power of x. I can tell you from these equations what everything means. This means in this equation that I started with 400 of whatever it was that I was counting. In this equation, it meant that I was starting with 1,000 of whatever. It could be $1,000, 1,000 bacteria. And in this one here, this meant that I'm starting with 850. These are all exponential functions or equations. How do I know that? Because I am multiplying here. How else do I know it? I've got exponents. All right, so we got initial amount is double underlined. All right, so now I've got this other number that I am going to draw a box around in orange. 2, 3, and 10. What that tells me is 2 means I'm doubling. That is how it's growing. It is doubling each time. The 3 means I'm tripling each time. And 10 means I am multiplying by 10, meaning it is a 10-fold increase. I am multiplying by 10. I don't have a fancy word like doubling or tripling. All right, guys, I hope that helps clear up any confusion that you may have had. You rewrite it. You should have no trouble answering the exit ticket or doing the homework. All right. Thank you for listening and watching.